Okay, so I'm just going to kind of restart what I said just because I started the video a little bit late. Okay, so we have the inverse is the reverse of the original function. So we have f at x, and then we have the inverse of x. So f at x is the function, which is f at x, okay? And the inverse function is f at x with the -1 here, okay? The f at x and its inverse undo each other, okay? So they kind of cancel each other out of the opposite, just like multiplication and division, addition and subtraction. So we're going to be following a few steps in order to find the inverse, okay? So the first step here is we're going to change the two variables x and y, okay? So we're going to switch them. So we're going to switch the spots of x and y. That's going to be the first step. Actually, the first step is to convert the f at x to a y, and then the second step is to change the x and y's position, okay? After we change, and I'll do this with the examples, after you change them, we're going to then solve for the new position of for y. Okay. Another side note is the graph of the inverse function is the reflection. I'll show you this. It reflects over y equals x. Okay, and I'll show you that in a graph. But a very, very, very important point here is the domain of the function is the range of the inverse. Okay, so whatever x values are used for the domain of the function become the y values of the inverse. Okay, and the range of the function is then the domain of the inverse. Okay, so they're opposite. So the domain of the function is the range of the inverse, and then the range of the function is the domain of the inverse. Okay, so your x and y values are swapped. And again, I'll show you with the examples. It might make no sense right now, but I'll do a bunch of examples and it should make sense then. Okay, so number one, find the inverse of the function f whose order pairs are these. Okay, so the function has these points on the graph. So -8 and 2, 0, -2, 3 and 4, 4 and 7. Okay, so this one we're not dealing with any equation right now, we're just dealing with points. Okay, so the inverse, so this is the function, the points of the function. The inverse will just have opposite points. Okay, so for the inverse, so f at x with the -1 on the top, the points are the opposite. So this one is -8 and 2, so the inverse is 2, -8. Okay, so we switch them. So the 8, -2 becomes 2, -8. Second point is 0 and -2. So the inverse is -2 and 0. Okay, we're swapping the points here. Then we have point 3 and 4 becomes 4 and 3. And our last one, 4 and 7, becomes 7 and 4. Okay, so the points are reversed for the inverse. Okay, so -8 and 2 becomes 2, -8. 0, -2 becomes -2, 0. 3 and 4 becomes 4 and 3. 4 and 7 becomes 7 and 4. Okay, so we reverse it. Okay, so now we're going to graph them. So I'll do them in two different colors. I'll do the function in black, and then I'll do the inverse in blue. Okay, so we're just plotting the point. So -2 and 8, 0, -2, 3 and 4, 4 and 7. Okay, so that's the point. The points for the function, and now I'm going to do the points for the inverse. So 2, -8. Whoa, it doesn't even fit here. It got cut off. -2, 0. 4 and 3. And 7 and 4. We're not connecting any of the dots, we're just graphing as it is. Okay, so one of the points above says it's reflected over the equation y equals x. Okay, so that plane is this. Okay, so y equals x, again, one of the points above, says it's reflected over the plane y equals x. So if you look at this, the points, they're reflected. So the function is here, the inverse is on this side. Oops, I accidentally erased one. Okay, function here, inverse this side. Function here, inverse on this side. The function up here is reflected over the y equals x. So this dotted line is y equals x. Okay, so just start to 0, 0, and your slope's 1 over 1. So it goes up 1 over 1, up 1 over 1. Okay, down, left 1, down 1, left 1, down 1. Okay, so it just goes square by square. Let's give you guys a minute to get that down. Again, so we just reverse the points for the function and the inverse. Okay, and then it gets reflected over the plane or the line y equals x. Any questions with that? Any questions?